This is a recording for Edexcel Further Pure 1. Inequalities, section 2.1, solving inequalities involving the modulus function. Well, the methods for solving inequalities involving moduli is basically the same as we've looked at before. We need to sketch the graphs of functions on axes, find the critical points where they intersect, and then use the graph to help solve the inequality. So I want to look at a couple of examples which illustrate these steps in the solution. So the first one then is solve x squared minus 3 modulus of is greater than 2x. So what we're going to do here is to sketch two graphs, one of them being y equals 2x, and the other one being y is equal to the modulus of x squared minus 3. Let's take that one first of all, the modulus of x squared minus 3. Well, if we look at x squared minus 3, it will go through negative 3 on the y-axis and then root 3 on the x-axis. So root 3 somewhere around about here and here. Remember, it doesn't have to be exact. So it's a x squared minus 3, it's going to be a parabola. As best I can do it on here is going to look something like this. Now for the modulus of that, the portion which is below the axis here will go upwards, so it will then go through plus 3 up here, will now look like this. So there's my sketch of y equals mod x squared minus 3. Y equals 2x is a straight line, of course, so that it will go through the origin and also will go through when x is equal to 2, y is equal to 4. And will be a straight line in this sort of fashion. And we can see there are two crossing points. One of them round about here and the other at this point here. So those crossing points we can find by solving algebraically the equation which says that the modulus of x squared minus 3, so mod x squared minus 3 is equal to 2x. Now there are two parts to this. One where the x squared minus 3 is greater than 0. So when x squared minus 3 is greater than 0, we could say that x squared minus 3 is equal to 2x. And that will give us x squared minus 2x minus 3 is equal to 0. And therefore we have x minus 3, x plus 1 is equal to 0. Well, the x is plus 3 is the one that we want. The other one, x equals negative 1, would be this point down here. But of course that's not a solution for modulus of x squared minus 3 is equal to 2x. And then when we've got x squared minus 3 is less than 0, we have to take negative of that. So negative of x squared minus 3 is equal to 2x. And therefore, if we rearrange that, we get x squared plus 2x minus 3 is equal to 0. And this time when we factorize, we get x plus 3 and x minus 1 equal to 0. So this time we want the one which is x is plus 1 which is this solution here. Now we want to solve our inequality, and from the graph we can see that if we want x squared minus 3 modulus of that greater than 0, we need the black line, the one which is the modulus, above the red one. So in other words, it's everything below the solution here at 1, so it's everything from there downwards, and then everything from the other solution at 3 upwards. So we have that x is less than 1 or x is greater than 3. Right, here we are, written out neatly, and of course we've got a better graph there than I could do on the computer screen, and you can see our solutions there at x equal to 3 and at x equal to 1, and then the inequality being solved from there downwards and there upwards. Remember, that must be done algebraically. You can't rely on a graph to give you those values accurately. Here's another example. This time we've got 4x squared over mod x plus 3 is less than 2. The first thing we need to do is to multiply by the denominator of the left hand side and divide by 2. So we get 2x squared is less than mod x plus 3, and then that gives mod x is greater than 2x squared minus 3. A graph of 2x squared minus 3 would go through negative 3 and be a parabola. So, for example, when x is equal to 0, we've got the negative 3. When x is equal to 1, it would go through 2 times 1 minus 3, which is negative 1. And so we get a graph looking something like this. Difficult to draw on the computer, as always, but it's about like that. Y equals mod x, on the other hand, will be y equals x, which is this line here, but then reflected as it goes into the negative part of the graph, it's going to reflect upwards, so it looks something like that. Now we want when mod x is greater than 2x squared minus 3, so we need to know when is the red line above the black, so it's between these two values that we need to find. So the first thing we need to do is to find the critical values when mod x is equal to 2x squared minus 3. And that we can say, well, when x is greater than 0, we have x is equal to 2x squared minus 3. So that 2x squared minus x minus 3 is equal to 0. And that factorizes 2x and x in the brackets. And the values we need are minus 3 and plus 1. So therefore, x is equal to 3 over 2. The x equals negative 1 is the point down here that is not relevant. And likewise, you can check that when x is less than 0, so that minus x is equal to 2x squared minus 3, this gives a value of x is equal to negative 3 over 2. So therefore, to solve our inequality, we can say that it must be between those two values. So therefore we have negative 3 over 2 is less than x is less than 3 over 2. There, rather better graph, and you can see the moduli. Remember then again, for watch us there, we've taken this part of the graph and reflected it so that it is positive. That's the end of this particular video, and in fact the only one in the section on inequalities 2.